Have you ever stood outside on a clear, dark night and looked up at the stars? It's a peaceful sight that connects us to our ancestors and each other. We all share deep questions about our cosmic home. NASA's powerful telescopes are peering into the universe's oldest parts, searching for answers. The observable universe is our cosmic horizon, what we can see and what remains a beautiful mystery. Let's take a calm journey together, exploring what we're learning about the edge of our universe. For most of history, our understanding of the universe was limited. The ancient Greeks imagined stars fixed to a giant sphere around Earth. This idea gave humanity a central place in a tidy cosmos. As knowledge grew, thinkers like Copernicus and Galileo showed Earth wasn't the center. The universe became much bigger, and the idea of a solid sphere faded. People began to wonder if the universe might be infinite. Even into the 20th century, we thought the Milky Way was the entire universe. Our cosmic map was missing most of the territory. Our idea of the edge has always been changing, defined by our vision and understanding. From a solid sphere to the edge of our galaxy, our map has been redrawn many times. Each new map was based on the best evidence available. It's a wonderful example of how science works. We create a model based on what we see. Then, when we get new information, we change the model. We are always learning, always expanding our horizons. The universe was no longer a cozy room. It was an endless open space. This was a scary but exciting thought. How do we see the universe's edge today? Not with a regular telescope. The light from the farthest parts is incredibly old and faint. NASA built amazing instruments like the James Webb Space Telescope, JWST. JWST is like a giant time machine, seeing infrared light our eyes can't. It's floating in space, 1,000,000 miles away, with a huge golden mirror. This mirror collects faint, ancient light from the dawn of time. Before JWST, we had the Hubble Space Telescope, which showed us distant galaxies, but Webb sees even farther back to when the first stars and galaxies formed. It's like being an archaeologist of the cosmos, uncovering our origins. Scientists point the telescope at a tiny patch of sky for hours, collecting light. The data is sent back to Earth, where scientists analyze it for clues. They look for how the first galaxies formed and what they were made of. It's a slow, patient process, like leaving a camera shutter open in a dark room. Webb is essentially looking at the edge of our observable universe, capturing the baby pictures of the cosmos. What is NASA finding with these tools? A surprising picture of the early universe. The James Webb Space Telescope reveals galaxies brighter and more complex than expected. It's like finding baby pictures showing a fully grown teenager. One shocking finding is the number of well-formed galaxies in the early universe. We thought they would be small and clumpy, taking billions of years to grow. But Webb finds galaxies that look mature, with distinct structures. It seems the universe built large structures faster than imagined. Scientists analyze the light from these galaxies to understand their composition. They find heavier elements, suggesting a quick cycle of star birth and death. The edge of the universe is not a quiet place, but a bustling environment. It was a cosmic nursery filled with robust infant galaxies. This doesn't mean our understanding of the Big Bang is wrong. But the early chapters of the cosmic story are richer and more complex. The universe was in a hurry to create complexity and structure. The universe, it seems, was in a hurry to create complexity and structure. Let's compare these findings with older beliefs. The hierarchical model suggested small things formed first, merging over time. It was a bottom-up process, like building a castle with Lego bricks. This model was supported by evidence from telescopes like Hubble. It predicted small, faint smudges in the early universe. But the James Webb Space Telescope shows something different. Early galaxies are not just small smudges, some are massive and bright. This suggests a faster or different building process. The hierarchical model isn't the whole story. Perhaps there was also a top-down process at play. Huge clouds of gas could collapse directly into large galaxies. The early universe was more efficient at building big things. The old map was good, but the new map reveals unexpected shortcuts. The new truth is that the early universe was more efficient at building big things. The old map was good, but the new map is revealing unexpected shortcuts. The new map is revealing unexpected shortcuts and expressways in cosmic construction. Let's delve into surprises that have left scientists puzzled. One shock is the discovery of universe breakers, massive early galaxies. These galaxies push against the limits of our cosmology theories. Another surprise is related to black holes. Webb finds enormous black holes in the early universe, flipping old ideas. Perhaps giant black holes formed first, acting as cosmic seeds. A massive black hole could form from a collapsing gas cloud. Its gravity would pull in matter, triggering star formation. The black hole is the gravitational scaffold for the galaxy. This shifts our thinking, suggesting black holes might be creators. Finally, there's the puzzle of the little red dots. Webb reveals tiny, extremely red objects, possibly quasars. If true, the early universe was filled with more cosmic engines than predicted. The deepest dark was glowing with activity. The deepest dark, it turns out, was glowing with activity. You might wonder why these discoveries matter. They feel distant from daily life, but they're important for deep reasons. First, it's about our origin story. Understanding the first galaxies helps us trace our cosmic family tree. This research tests the limits of our fundamental physics laws. Cosmic surprises are clues pointing to new physics. They lead to a deeper understanding of reality. These discoveries show the importance of human ingenuity and collaboration. The James Webb Space Telescope is a testament to global cooperation. It demonstrates our shared capacity for curiosity and creativity. Finally, this knowledge gives us perspective. It connects us to something vast and ancient. It encourages awe and humility. It reminds us we're part of an incredible cosmic story. This perspective can be calming and inspiring. It helps us appreciate the beauty and fragility of our world, our place within this grand universe. We are at a wonderful moment in history. The old maps of the cosmos are being redrawn. The universe's edge is a vibrant frontier challenging our ideas. This is science at its best: discovery, questioning and surprises. The journey into the unknown doesn't end here. Every new discovery opens up new questions. Scientists will study this data for years, developing new theories. There will be more surprises and moments of awe. The quest to understand our universe is a fundamental human journey. I encourage you to stay curious and keep looking up. Trust science to guide us toward answers. The universe is under no obligation to make sense, but we can understand it. The path forward is lit by curiosity and courage. It's a journey that enriches us, expanding our knowledge and wonder. If this journey excites you, continue it with us. Our community shares a passion for discovery. You don't need to be an expert, just curious. Join us and let's explore the edge of everything together. The greatest discoveries are still ahead, waiting in the starlight.